I want to tell you a story, the story of the trampolining tardigrades. It begins in the strange world of the quantum, where uncertainty is the rule rather than the exception. In fact, uncertainty creates the rules. Reality emerges from the underlying randomness of quantum mechanics. In quantum theory, matter isn't made from particles like tiny billiard balls, it's made from waves. Little bunches of waves act like a particle, but they also act like a wave. Waves can add together to create more complex waves. Drop a stone in a pond and you get an expanding circular pattern of ripples. Drop two stones in and when their circles cross you get complex patterns. Peaks and troughs reinforce each other, but peaks cancel out troughs. This is called superposition. Now, you've probably heard of Schrödinger's cat. In the early days of quantum theory, Erwin Schrödinger invented a thought experiment to dramatise quantum superposition and its puzzling relations to observations. Basically, he said, in quantum theory, a cat in a box can be both alive and dead at the same time, but you can't find out which until you open the box. Cats, as far as we know, can't actually do this, as Schrödinger pointed out. In classical physics, a cat is either dead or alive, but never both at the same time. Since cats are made from gazillions of quantum particles, however, this is a puzzle. We don't fully understand how our familiar world of classical physics emerges from the weirdness of quantum mechanics. It may be because large collections of particles interfere with each other and destroy superpositions. Anyway, Schrödinger didn't believe you could do this with a real cat. He was worried about the meaning of a quantum observation which somehow collapses a superposed state into a single classical one. Other physicists, slightly missing the point, showed that simpler systems do behave like that. A photon, the fundamental particle of light, can exist in superposed states. The same goes for an electron, the particle that produces electricity. Over time, physicists have performed experiments showing that ever larger quantum systems can behave like Schrödinger's cat. They've created superposed states of atoms of beryllium and a quantum tuning fork composed of 10 trillion atoms that vibrates and doesn't vibrate at the same time. But those systems are much simpler than a cat and they're not alive. Getting closer to a cat, some physicists have proposed putting an influenza virus into a superposed state. They haven't yet done the experiment, and anyway it's questionable whether virus is truly alive. Recently, Simon Groblacher proposed a more ambitious experiment, using tiny creatures called tardigrades, slow steppers. The German zoologist Johann Goethe discovered them in 1773 and called them little water bears, because they look a bit like bears, except they have 8 legs and are 0.5 millimetre long. Another name is moss piglet. Groblacher's idea is to make a quantum trampoline, a square membrane 1 millimetre across. It ought to be possible to put the trampoline into a superposition of up and down at the same time. If so, the next step is to put a tardigrade on it, which should then also be both up and down at the same time. Not quite Schrödinger's cat, but the next best thing, Schrödinger's moss piglet. I hope he does the experiment. I want to see how it turns out.